Greetings, fellow mathematicians. We're going to take a look at another trig integral involving powers of sines and cosines, but this one involves a little bit of extra work, and that work is fairly standard for these types of problems. So you'll definitely want to make sure you watch this video all the way through to see those extra steps. We'll point that out when it comes up. Now, your basic idea for these is use substitution, split off a factor for du, and then use a Pythagorean identity to convert the rest of it to your substitution. Now, powers of sines and cosines are the simplest of the two cases, and as long as there is one odd power, they pretty much work themselves out. And we have an odd power here, an odd power of sine, so let's split off one factor of sine of x and go from there. So if we split off one factor of sine, we'll be left with sine to the fourth. We have our cosine squared factor, and we're going to put that factor of sine of x that we're splitting off at the end next to dx. All right, now there's a lot of different things you can memorize here for these types of problems, but I prefer to teach this by keeping in mind what you split off is going to be reserved for du, and you can work backwards from there. So if your du, or derivative, or differential, is a sine, that means your u must have been a cosine. We're going to let the negative work itself out. So let's try as our substitution u as cosine of x. Calculate your differential du. The derivative of cosine is negative sine of x. And here's where we'll convert with the negative. Sine of x dx, well, that doesn't convert to du, but if you bring the negative over, you can rewrite this as negative du equals sine of x dx. That's the idea of manipulating a differential, which is very common for u substitution. We're just doing that here with the negative. All right, so if we convert sine of x dx, that converts correctly to negative du. All right, our substitution was u equals cosine of x, so cosine squared, that easily converts from x to u. That's just going to convert to u squared. But how do we convert sine to the fourth power of x to u? Keep in mind, the two basic ideas, split off something for du, and then convert the rest of it using a Pythagorean identity. And let's go through that work right now. The Pythagorean identities, those involve sine and cosine squared. This is the extra work that I mentioned at the beginning of the video in the intro. We're going to use some basic properties of powers. So let's take sine to the fourth. And if we're trying to use Pythagorean identities, we need to rewrite this involving sine squared. So let's use some basic properties of powers. I'll rewrite this as sine squared of x squared. Notice your outer and inner powers would multiply, and they multiply correctly to 4. All right, now we can convert this. The inside of the parentheses or brackets, that's where we use a Pythagorean identity. Sine squared of x, we're going to convert that to our substitution involving cosine. We're going to rewrite sine squared as 1 minus cosine squared. And if we just plug that in inside of those parentheses or brackets, we get 1 minus cosine squared of x squared. And now we can plug in our substitution, u as cosine of x. Inside the parentheses or brackets, you're going to get 1 minus u squared with a square on the outside. And that is the standard extra work that's going to happen for a lot of problems you'll encounter on tests and exams in your Calc 2 course. All right, so let's go ahead and plug that in. That was the conversion for sine to the fourth power of x, which converts to 1 minus u squared squared. All right, and from here, we just need to be careful with our algebra, and we're going to clean up the integral. we have a negative, which I'm just going to pull at the beginning of the terms inside our integral. So let's rewrite this as the integral of negative. We'll have a factor of 1 minus u squared squared. And don't forget the factor of u squared in the middle. And that's multiplying du. All right, from here, we just need to go through some basic algebra, properly expanding 1 minus u squared squared. So let's go ahead and do that up here. All right, make sure that you correctly expand, multiply, or FOIL that. You'll get 1 minus u squared for outers and inners, so minus 2 u squared. And then multiply your last terms, that's going to be plus, the negatives cancel. And then add the exponents u squared times u squared will give u to the 4th. All right, let's go ahead and plug that into the parentheses there. We multiply that out. I'll keep the negative. We got that as 1 minus 2 u squared plus u to the 4th. And we have the factor of u squared at the end there. All right, let's do two things. I'm going to distribute u squared in, and at the same time, I'm going to use this negative to change all the signs inside the parentheses. And we'll be left with a very simple looking integral. All right, so just be careful here. Distribute, you'll get u squared, but negative. So I'll write that as negative u squared. The negative distributes to give you positive 2. And then add your powers, u squared times u squared. They add to give u to the 4th. Distribute your negative in, you're going to get now minus. And multiply there, distribute in, add your exponents, u to the 4th times u squared. They add to give u to the 6th. And now we can just apply the power rule to each of those three terms. All right, if we do that, looks like term by term, we're going to get negative 1/3 u cubed. The next term will integrate to 2/5 times u to the 5th, and then minus 1/7 u to the 7th power. And your last and final step, like in all substitution problems, convert from u back to x, and we were using u as cosine of x. So if we just plug that in everywhere, we're going to get our antiderivative involving powers of cosine. So if we write it down, we'll get minus 1/3 cosine cubed of x plus 2/5 cosine to the 5th power of x, and then minus 1/7 cosine to the 7th power of x. And that is our antiderivative for this trigonometric integral. All right, the work was a little bit more, and most of it occurred from there being not just sine squared, but sine to the 4th power of x. We converted that using a Pythagorean identity by rewriting that as sine squared squared. So just be careful of that, especially be on the lookout if you have some rather large powers, like sine to the 6th power, which you could think of as sine squared cubed. We'll have those in other problems. Hope you enjoyed the video. I hope you're learning a lot. If you are, support the channel, like and subscribe.